All right, so I've got a couple of questions here that I wanted to just go over for unit conversions, because it is a super confusing topic in chemistry. So first thing I want to do is just a straight unit conversion, and then I'll add some complexity and some chemistry vibes next, and then we'll get to an even more complex one. So first one is just convert 72 miles to kilometers. Now, this would be super easy to just like Google and stuff, but I'm going to actually show you like the longhand using only information that is somewhat common knowledge. Like these things are things that for some reason are stuck in my brain and I don't really know why, but it's just there. So for me, I know how many feet are in a mile, how many inches are in a foot. Those are pretty common usually of conversions that work. And then I also know how many centimeters are in an inch, and these are just kind of some helpful things to have memorized. And how many meters a centimeter, how many centimeters are in a meter, and how many meters are in a kilometer. So I'll kind of show you that whole way to go from miles to kilometers. And what I often tell my students is to let your units guide you. So things like miles and kilometers, and this is why your teachers always forever said, like, write down your units. It didn't matter then, but it's starting to matter now, because for me, I make a little roadmap that says I'm going to go from miles to feet, because I know how many feet there are in a mile. And then I'm going to go from feet to inches, because I know how many inches there are in a foot. And then I'm going to go from inches to centimeters, because for some reason that's a piece of information that exists in my brain. And then I'm going to go from centimeters to meters, because that's going to meters in the metric system is the kind of home base. And then from meters, I'll go to kilometers. So I've got myself a little roadmap here, and I always start with what the problem gives me. And then like you had written down on that piece of paper you showed me, was you had like a piece of information that was written as a fraction. Now, the reason that works is because I know that 1 mile, this is applicable for this particular instance, 1 mile is the same thing as 5,280 feet. That's just the definition of a mile, just like 1 foot is equal to 12 inches, right? So I'm going to just use this miles example for a second first, because when you have two things that are equal to each other, if you think about, for example, 7 divided by 7, let's say, that just equals 1, right? So when you have two things that are equal to each other, like miles and feet, when you divide one by the other, 1 mile and 5,280 feet, when you divide one by the other, what you really get is 1 mile divided by 5,280 feet. That is just equal to 1. Now, the reason that's important is because when you multiply 72 by some kind of conversion factor like this, you're not changing the value, because you are only multiplying by a factor of 1. And when you multiply anything by 1, you just get that same thing. It just looks different. So I almost think about these almost less of conversion factors and more of like translators. So like if you were to say hello and you wanted to say hello in Spanish, you'd need someone to translate for you to say, oh, it's hola, right? So these are kind of translators. And the way that you pick a translator is this right here is true, but because these two things are equal, this is also true, right? This also equals 1. So I could use either one of these. Now the question is, how do I decide which one to use? And this is where units guide me, because back over here, I'm going to look at the fact that I have miles and I want to cancel miles off. Well, in algebra, the way that we cancel things off is if it's being multiplied, the opposite of that is division, right? Or if you divided miles by miles, it just equals 1, just like 7 divided by 7 equals 1. So what I'm going to do is, rather than writing that right under here, I'm going to actually write that over here so that I can preserve one of these unit conversions that I have over here. Now, the one that has miles on the bottom is going to have the 5,280 feet in the top. So I'm going to put that 5,280 feet. The way that I kind of keep track of all this too is I like to make sure that my units are actually canceling. A huge common misconception or like point of confusion is mixing up miles and meters. And so I just want to make sure that I've got miles here and I'm not getting confused that way. Okay. So now I'm going to go to the next thing, which is another conversion factor. And I'm just going to string out a whole bunch of conversion factors. I wrote down the conversion factor that 1 foot equals 12 inches, right? And so I could write that as 1 foot over 12 inches, or I could also write that as 12 inches over 1 foot. The one I decide to use is looking at the previous unit. So right here I have feet, and I need feet to cancel, so feet needs to go in the bottom of the next unit conversion. So I use the second one that I wrote right here, 12 inches over 1 foot, because feet cancel with feet, just like that. Okay. And then for whatever reason, the next fact that I know is that there are in 1 inch, there are 2.54 centimeters. And so that is always the conversion factor almost that I use to get from distance in imperial, or what we use, into metric. I almost always go down all the way down to inches, then convert to centimeters. So I'm going to say 1 inch on the bottom because inches are in the top previously, and 2.54 centimeters are on the top. Now the inches and inches cancel again. Okay, and then the next one I can say is that I know 1 meter, actually, and remember not to confuse meters and miles, but that has 100 centimeters, okay? So then I can say 100 centimeters on the bottom and 1 meter. Notice centimeters are going on the bottom because centimeters were on the top and I need them to cancel, just like that. So there we go. And now the only thing left to do is to get to kilometers, which there are, in 1 kilometer, there are 1,000 meters. Okay, so these are pieces of information that I just have, but they're kind of common. They are pretty common, and it's good to have them memorized. The way that you'll usually memorize these is just by using them over and over. Finally, this will get me 1 kilometer over 1,000 meters. Didn't leave myself enough space. Those meters and meters cancel off too. So now, as I look back through this, I can see, just like my roadmap was up here, I can see meters go to feet, to inches, to centimeters, to meters, to kilometers. Okay, so I just kind of followed my own roadmap using the information that I knew. And then I can see that the only thing that has not canceled off is this kilometers, which is great because I'm wanting to convert to kilometers. Okay, so now the trick is going to be to enter all this into your calculator. Now, before we do that, I did want to just show that, like, because this is one thing being divided by itself, just a different version of itself, remember that these are all just big factors of 1. This is what I always do to help my students see it. You're just multiplying by a whole bunch of big factors of 1, right? Because we're not changing the actual distance. We're just changing the way we represent that distance, just like it's a different language, right? So we're just multiplying by 1 times 1 times 1 times 1 times 1 to get to a different language or a different set of units, okay? So now the part would exist where you have to enter this into your calculator. Now, I always multiply everything on the top in the numerator, and then I'll divide by everything in the denominator. And I'll give you a little hint here too when we get there. So I've got 72 times 5,280 times 12 times 2.54. And then because these are both 1, I don't actually have to multiply or divide by them because multiplying by 1 doesn't change the value. Dividing by 1 doesn't change the value. However, when I do put this in my calculator, if I were to just go divided by 100 times 1,000, which is what I have right down here, my calculator would actually read it as all of this 72 times 5,280 times 12 times 2.54 divided by 100. And then my calculator would take that quotient and it would multiply that by 1,000, which is not going to give me the correct answer. So what I actually need to do is I need to make sure that I put this in my calculator in parentheses so that the calculator reads it properly. Now, depending on your calculator too, it may be more beneficial to do all this multiplication and put it in, like, write down the answer up at the top, then do all this multiplication on the bottom, write the answer down on the bottom, and then divide the top by the bottom, if your calculator doesn't have enough space or doesn't have like parentheses that make sense. So I'm going to plug that all into my calculator and get a number for us real quick. And I got 115.9. And this is kilometers, because that's the only unit that didn't cancel off, right? So I have successfully now converted from miles to kilometers. Now, there is a quick note just to make about significant figures. It's something that's pretty common in chemistry, and there are some rules for significant figures. We could go into those more in depth if you need to, but there are some rules that you can look up. And just for now, I'll suffice it to say that there are two significant figures here. And for whatever our question gives us, that's what we should represent our answer in as well. So you look at the leftist most digits, and we're going to round those, which this is a 5. So that's going to round this next one to the left up to 120 kilometers. Okay, so that is even representing just these two significant figures. Okay, so there's the first one on unit conversions. Try to let your units guide you, see how they cancel. The next one is, and this is more chemistry based, is what is the mass of 6.73 times 10 to the 27th atoms of chlorine? So right now we're going to start with 6.73 times 10 to the 27th. We generally start with what the problem gives us, and this is atoms of chlorine. Now, when it says mass, I don't know how much the mass of a singular atom of chlorine is. The periodic table actually tells me instead, more specifically, what the mass of a mole of chlorine is. So it says that the mass of 1 mole of chlorine equals, I think it's 35.45 grams of chlorine. Okay, sorry, I had to write that on another line. But this goes from a mole to the mass. But I have up here listed in atoms, right? So what I need to do is figure out a way to go from atoms of chlorine to moles of chlorine, then finally to the mass of chlorine, which will be in grams. Just like that. So going from atoms to moles to mass. Now, this conversion factor right here, we use, and you had this written down as well, but we use Avogadro's number, which is that 6.022. I've always used 6.022. Some people use 6.023 times 10 to the 23rd atoms, though. And that's what tells us that there are 6.022 or 023 times 10 to the 23rd atoms of anything, or 6.022 times 10 to the 23rd of anything, and I'm going to go with 0.022, of anything in 1 mole, but since we're working with atoms, we're going to say that that's equal to 1 mole of chlorine. Okay, so in doing this, we can take this and put it into a unit conversion just like we had up here, just like any one of these. Okay, so we've got to figure out which one needs to go on the bottom. And again, because I've got atoms right here that I'm starting with, that's what I want to cancel off and just be left with moles. So I'm going to put atoms on the bottom and go 6.022 times 10 to the 23rd atoms of chlorine. And again, these units, I always make the sound effect, pew pew. It's ridiculous and silly, but I feel like it's right for a science teacher to be that way, isn't it? So there we go, our atoms canceled off. And now I know over here, because of what the periodic tells us, that 1 mole of chlorine has a mass of 35.45 grams. So I can say, because moles are up here, I can put moles down here and say that 1 mole of chlorine, which moles are often also abbreviated as MOL, kind of silly, but That's the way it is. And they have a mass of 35.45 grams of chlorine. Now, when I'm looking at that, it asks me what the mass is. And so now that I'm in grams right here, we're good, right? These moles cancel off, and I can just go ahead and plug all this in. Now, on a calculator, you would want to do 6.73 times 10 to the 27th, times 10 to the 27th, times the 35.45 grams. Again, grams are the only thing that haven't canceled off. And then in the bottom, I've got 6.022 times 10 to the 23rd. So this is kind of neat, actually. This times 10 to the is represented on your calculator as a capital E right next to each other. Depending on your calculator, it could be like a second squared button or something like that. So you can try to find this capital E, and then you would just type in 6.73 EE and then 27. That's all you would put in your calculator, and that recognizes it as 6.73 times 10 to the 27th, which is pretty cool. So this one, we're going to do multiplication on the top and then divide it. This would also work as an EE. So I'm going to put that into my calculator real quick and double check, or just get that answer as well. Your phone calculator should have this too. If you hit it sideways, you can do the 6.73 EE 27. This is also why sometimes your calculator will represent things like 3.962 times, and it'll say, instead of times 10 to the, it'll just say EE, like this. Okay, so this is the number of grams that we would have. You could also take this to kilograms if you needed to, because it's a pretty big number. I'm just going to leave it in grams right now. The way that you would go kilograms is just like we did meters to kilometers. 1 meter has, or there are 1,000 meters in 1 kilometer. There are also 1,000 grams in 1 kilogram. So you could even go 1,000 grams to 1 kilogram if you really wanted to. I'm not going to right now, but that's something, if your prof wants you to represent it like that, you could do. I'm going to use significant figures, or sig figs again. Up here, this has given me 3 sig figs. Avogadro's number has 4 represented right now. This mass has 4 represented right now. But when we have things that are given to us like Avogadro's number, that actually won't limit us because it's the definition and it already has sig figs kind of counted in, so it doesn't usually limit us. But either way, 3 is less than Avogadro's number anyway. So I'm going to round this right here to 3 sig figs, the 3 leftmost significant figures, and this rounds that 6 down to the floor, so it's going to be just 3.96 times 10 to the 5th grams of chlorine, just like that. Okay, last one I'm going to do is a little bit more complicated because we're going to be dealing with the numerator and the denominator. So this says, how fast is 35 miles per hour in meters per second? Notice again that this is miles, this is meters, right? So just to differentiate those. So we went in our first problem from miles to kilometers, which included getting us from miles to meters. Now that's where we're going to stop this time. But we also have this denominator where we're going to go from hours to seconds as well. So let's deal with one thing at a time. I'm going to take what the question has given me first, 35 miles. And anytime you see a per, so even like an MPH is a little tricky because this looks like meters, but in the US we know that that's miles per hour, right? But MPH even is really saying miles per hour. So that per is actually a division symbol. So when I've got miles per hour like this, I'm going to represent it as 35 miles over 1 hour. So now you can see that this is almost like a conversion factor itself because I'm going 35 miles and that's equal to the time of 1 hour. But because I'm starting with that, that's just going to be my basis. Okay. Now we can deal with these things separately. We can deal with miles first, and we'll do it just like we did before. It'll be miles to feet to inches to centimeters to meters. And then we're going to stop right there because we just need it in meters. So let's do that part first. In 1 mile, I know that there are 5,280 feet. Boop, boop. Those cancel. Then in 1 foot, I know that there are 12 inches. Boop, boop. Again, I'm putting the thing that needs to cancel where it will cancel, right? Since miles are up at the top, they need to be at the bottom over here. Since feet are up at the top, they need to be at the bottom over here. Inches, since they're at the top, we're going to say 1 inch is 2.54 centimeters. Remember that these are all just conversion factors. They're just all, they're translating from one unit to another. And then finally, there are 100 centimeters in 1 meter. And we get all of these to cancel off, right? Now we need to deal with, so we're good. We've got meters up at the top. That's what we want. But now we need to deal with this hours. Now you'll notice I said that since miles were up top here, they go on the bottom here. But now since hours are on the bottom, in order to cancel them, I need hours to go on the top. And I can actually just pretend like none of this really exists. It does, but I'm just going to continue the hours portion right out here. And I'm going to say, to get from hours to seconds, I know that I could go from hours to minutes to seconds. So that's what I'm going to do. And I'm going to say that 1 hour has 60 minutes. Notice that these can cancel, even though they're far apart, they can still cancel because it's all just multiplication and division. And then here, I've got minutes on the bottom, so minutes need to be on the top over here. 1 minute is 60 seconds. Minutes cancel, and I've got now seconds on the bottom. So I've got meters per second because meters are left up here, hours and minutes canceled, seconds are left down here. So my units have helped to guide me to that point. And now I can just go ahead and put all of this into my calculator, right? So I'll go 35 times 5,280 times 12 times 2.54. And then it's times 1 times 1 times 1. That doesn't matter. Okay, and then I'm going to go divided by 1, 1, and 1 don't matter, but the 100 does. So 100 times 60 on the bottom times 60. Now again, I need to make sure that if I'm plugging this on my calculator, I need to do the whole thing in parentheses like this, or my calculator will read it incorrectly. So I'll go ahead and put this in my calculator real quick. And I have that equaling 15.646. Okay, and that is, the units are meters per second, which is excellent. Now again, significant figures are a thing in chemistry, and they're basically just telling us how accurate our measuring tool was. So our measuring tool was measuring to like the singular mile versus like the 1/10 of a mile. If we had done 35.0, that would be more specific, right? But we're just saying that whatever measuring tool we had was only going to the 1 mile, 1 whole mile. So this is saying there are 2 sig figs. So I need to represent this with 2 sig figs, which are the leftistmost. This one is a 6, which is above 5, so that rounds up. 5 or above rounds up. So this is going to be 16 meters per second. So that is the speed of 35 miles per hour. All right. Hopefully this has helped you out a little bit and made it easier to understand. Just remember that all these are big conversion factors of 1. They're not changing the value. It's saying that this speed is this speed. It just looks different, just like a translation. All right. Hope it helps.